Hey, what's up guys? Welcome back to Mr. Deep Coding channel. Now in today's episode of our KMM social app series, we will be on the backend and we're going to work on the login and the registration. Now if you downloaded the IntelliJ IDE, like I told you in the first episode, and I hope that you did, by the way, you need to go to this website and download this community edition. Now, with the community edition, we can't create a Ktor project directly inside the IntelliJ IDE. We will rather use this website, start.ktor.io. I will include the link in the video description. So head over to this website and we're going to create our project. Now, first thing first, going to give that a name, and mine, I will name that as social app Ktor. So after giving our project a name, going to adjust project settings. First of all, we change the website. For me, I will call that mrdeep.com. So next we need to choose a Ktor version for our project. I will use the latest one, which is 2.2.4. Next we need to choose an engine. I will use the default, which is Netty. And for the configuration of our project, I will choose code like here. Alright, you need also to make sure to include this to add sample code. So next we need to add plugins to our project. You need to click on this button here, add plugins. So let's see what plugins we'll need for today. First of all, we need an authentication plugin, so you need to click on this add. Let me scroll down. So what else do we need? For authentication, we're going to use JW2, which stands for JSON Web Token. You also need to include that. Let me scroll down. You can see that routing has been added as well. Static content, we don't need that for now, but we'll use that to send images. So let me scroll. So for serialization of data, we're going to use Kotlin X serialization. So you need to include that as well. And that also add this content negotiation. And let me scroll again and see if there is anything that you need. Yes, for database, to communicate with our database, so we're going to add this expose library, and we'll be using Postgre database. You also need to add that. And I think that's all for now. We added 7 plugins. So after you add all your plugins, you can now click on this generate project button. As you can see, our project has been generated. You need to unzip this file here and open that inside our IntelliJ IDE Community Edition, and I will find you there. Alright guys, now as you can see, I'm inside IntelliJ IDE and I've got the social app Ktor project opened. So the first thing that I would like you to do is to open this build.gradle.kts file. And as you can see here, besides these dependencies that were added when we configured our project, I have included 2 dependencies here. On one hand, coin Ktor for dependency injection and Hikari for database pooling. We'll come to this later, but for now you need to declare these variable versions here on top of this build.gradle.kts file. Now the versions are inside this gradle.properties. Here are the versions. You can type them or copy them directly from my GitHub repository. Now after you include these 2 dependencies, you can click on this load Gradle changes. This is the equivalent to sync now from Android Studio. Right, so I'll skip the video until the build is done. Great, so the build is done. I'm going to close these 2 open file. Now let's expand the SRC and see the sample code that were added by Ktor. So I will also expand this plugins package here. As you can see, we've got a bunch of files that were created. These, for example, this schema.kt, ctschema.kt here, we don't need it. It's just a sample code showing how you can interact with your database. So going to implement our own schemas later in this video, so I'm going to remove that. I will remove this database.kt as well. Let's open routing.kt. So for now, I will leave this because we're going to test and see if we can get a response. Open security.kt. Yeah, here it's just a normal configuration of JWT. Yeah, we'll come to this JWT later. Open serialization, and we can remove this routing here, but we're going to leave install content negotiation because we need that. And user schema.kt. This is another database manipulation sample file that were created. We don't need that. Let's remove this. Lastly, we're going to open application.kt. We can get rid of these configured databases. So yeah, I think that's all we need to remove for now. Now we can test our app and see if we didn't break anything. For that, you can run this main function here. You need to click on this green icon and then click run application kt. Alright, so as you can see here, we're getting an error. So let's read and see what it says. Exception in thread main, property JWT audience not found. Alright, so let me close this. So if we go back inside security.kt, you can see that to configure our JWT, we need a JWT audience and some other properties that we're loading from environment.config. But this property here does not exist inside. These properties here, JWT audience, JWT domain, etc., they don't exist anywhere inside our project. So I'm going to add these properties to our environment variable. So to add this to our environment variable, first I'm going to copy this jwt.audience, click on this application kt here, click on edit configuration, and from here you can see that we are able to add environment variable. So to add a new environment variable, you need to click on this edit environment variable, then click on the plus sign here and paste your jwt.audience. For the value, you can give it your audience value. For me, I'll give that as users. That's the audience for this Ktor application. Click on apply, then click OK. We're going to do the same for JWT domain, but this JWT realm here, we don't need it, at least in this project. So I'm going to remove that. Let me also expand this a little bit. Now we can copy this jwt.domain and create a new environment variable as well. For the domain, I will just give that as mrdeep.com. Here normally you would give your website, but I don't have any website, so yeah, just keep this. Click OK, click apply, and again click OK. So we're going also to add a JWT secret key that will be used to generate or sign our token. So normally here you should give a strong secret key. I'm showing you this because I don't have any secret key in my mind for now. But yeah, keep in mind that here you should provide a secret key that you are the only person to know, and you shouldn't share that with anyone else that you don't trust, because if they got this JWT secret key, they can generate tokens, and there will be valid token, there could be verified token. After adding this, I'm going to click OK, apply, and then OK. So we need now to call our environment variable. So I will cut this and instead write system get env and then paste our JWT audience. We'll do the same for the secret. Great, so after adding this environment variable, we can rerun our application and check again if we didn't break anything else. Cool, I think the application is working. As you can see, Ktor application responding at HTTP localhost 8080 as the port. Now I'm going to open this inside Chrome. And okay, so we're getting the hello world message that were here inside routing. You can see the default hello world that we're getting from our default endpoint. Yeah, I think that's working. So I'm going to close this and close all of them. So the next thing that we need here is a database, and like I told you, we're going to use PostgreSQL. So head over to this website here, postgreapp.com. You need to download Postgre app and install that in your system. And after you download and complete the installation of Postgre app, we're going to launch the application. So for that, I'll go inside my application and click on Postgre because I've got Postgre already installed in my computer. So as you can see, I'm running, I think, the latest version of Postgre, which is Postgre 15. And I've got some databases that were created. These three databases here, the one with my username, the Postgre and template one come by default, and it's Postgre who create them. Now this social app DB here is the database that I'm using for the demo project that I'm working on as well. Now we need to create our own database for our new project. So for that, I'm going to quickly open terminal. Let me zoom in so that you can see. And from here, you need to add this PSQL executable to your system path. I mean, you need to add this executable to your computer's path. And to get the location of this, let me go back, Postgre. You can double click on one of these databases here, and that will give you the path to your PSQL executable. You can copy this and Google how to add PSQL to my computer's path. So after you add that, you can directly execute commands. Let me zoom in so you can see. The path to my PSQL executable is this one: application, Postgre app, content, etc., etc. You need to copy this and add that to your computer's path. That way you can execute PSQL command without having to double click on any database directly. So inside here, I'm going to write this PSQL and hit enter. As now you can see, I'm connected as Mr. Deep, and I can execute PSQL, Postgre's command directly. So the command that we need here is the one to create a database. So I'm going to write that, create database. So our database name, we give that as social media DB. Put a semicolon and press enter. As you can see, a database has been created. Now if we go back in Postgre, you can see that we've got here one more database that were created successfully. Now, after creating this database, we need to go back inside our project, inside our Ktor project, and try to connect this, connect our application to this social media DB that we have just created. So let me close this. We can also close this, terminate. Now back inside IntelliJ, we need to, let me first close this plugins package. I'm going to create one package here that I will name DAO, database, data access object. Normally you know these patterns from Android when using Room. So inside this DAO package, I will create a database factory Kotlin object, database factory. So you need to select object. Now inside this object, I'm going to declare a new method, init method, from which I will try to connect to my database. And for connecting to our database, you need to call a database, the one from JetBrains.expose.sql, and call the connect method. Now, as you can see, the connect method can take either a URL, which is a JDBC URL, and a driver class, or you can provide a data source. We're going to use this option here, the one to provide a data source, and for that we need a carry data source. To get a carry data source, I'm going to create a new private function here that I will call create a carry data source. This will return an instance of Hikari data source. So from here, our Hikari data source need an instance of Hikari config. So I'm going to create that quickly. Hikari config. We need Hikari config dot apply. So inside this apply block, we're going to set up the configuration for our Hikari. So I'm going to first of all declare here a driver class. So this will be as org.postgresql.driver, that the driver for our PostgreSQL. We also need a JDBC URL. Now the JDBC URL is a string that specifies the address of the database and the method used to connect to our database. So in this JDBC string here, we're going to basically give the address of our database and how we can connect to our database. So first of all, we need to put a JDBC, then the protocol that we are using, which is PostgreSQL. We need the host name for our database, and that is localhost. We need the port in which we are listening incoming request. For that, Postgre uses by default 54 and 32 as the port, and the name of our database, which is social media DB. Now with these two here, the driver class and the JDBC, we can configure our Hikari. Now set a driver class. We'll set that to driver class. We can set JDBC, pass in our JDBC URL. Now we need to set the maximum pool size, the maximum number of database connections that Hikari will create and manage for us. I'll set that to 3. Let me add space here. Alright, now these two here is auto commit and transaction isolation, is to make sure that Hikari uses the same default parameter as our exposed framework. And lastly, we need to call validate function. Validate. And now we can return a Hikari data source. and pass in our Ikari config. Next. Now to connect, we need to pass the create Ikari a data source here. So this way, what we have done here is that we have established a connection to our database, not a real connection, but a descriptor for future connection. So until you call this transaction, no real connection will be established. Now we have established a real connection to our database. We need to call this database.init function inside our application.kt database factory. Where is that? .init. Now let's rerun our application and see if we didn't break anything this time. So I'll rerun this. Great, we're having problems. Let me see. Database doesn't exist. Social media DB. Yeah, I misspelled the name of our database. Yeah, it's social media. This way. Now let's rerun the app again. Great. Yeah, I can see that we don't have any problem. I think it's still working and there's no problem. You can open and we're still having this hello world. Now we successfully connected to our database since there's no error. So I'll go back inside IntelliJ and close this. Now next thing that we need here is a user's row or our user's table, because when we sign in a user, we need to register the information inside our database. So for that, we need to create a user's table. Going to create that directly inside our Ktor application. So for that, I'll create first of all a new package that I will name model, and inside this model package I'm going to create a Kotlin file that I will name a user. Select file. Now here we're going to create our users table, and for that I will call this object from Kotlin and call my object as user row. This need to extend table from jetbrain.expose.sql. Give your table a name. I'll call mine users. Now inside this user row object is where we're going to define our columns. First of all, we need an ID, and that is an integer. The column name will be user ID, and dot auto increment because it will be an auto increment column. We need a name for our user. This is a varchar. The column name will be username. The length will be 250. Next, we need an email, which will be a varchar as well. The column name will be user email with the same length, 250. We need our bio for our user, and this is going to be a text. The column name will be user bio, and this will have a default value that I will set to and we also need a password for our user. This is going to be a varchar. The column name will be user password. The length will be 100. We also need a user profile URL that I will call avatar. It's a text. Column name will be user avatar, like so. And this is nullable. Now we need to override the primary key. So I'll call here primary key, and we're going to override that using our ID that we defined here. So the ID will be used as our primary key. Let's remove this also. Now, after inserting or after logging in our user, we also need to get a user object back. So for that, I'm going to create a data class that I will call user. Now this user here will be returned whenever we need information for our user. For example, when a user logs in, we need to give them back information about them, and when also we create a new user or when we insert a new user, we also need to give some information back. Alright, so our user needs an ID that will be of type integer. We need a name that will be a string. We need a bio that will be a string as well. Need to return also the avatar, nullable string, and we can return as well the password as well, because we're not going to return this directly as a response to the client, but we need this in our repository in order for us to check if the input password when a user tries to log in matches with our password registered in our database. So what I mean here is that we need this password because in our repository we need to check if the input password or the parameter password that will be passed by the user actually matches with the password registered inside our database. Alright, so now that we have our users table ready, we need a way to create that, and for that we can go back inside our database factory, and inside this transaction is where we're going to call schema utils from expose.sql and call the create function, and from here we're going to pass user role like so. Now let's rerun our app and see if the table has been created inside our database or not. Rerun the app. Great, the app is working. Now let me close this. I'm going to open terminal again. So from here I'll create PSQ, I'll call PSQL, and I'm going to connect to our database, social media DB. Now you are not connected to the database, so I'm going to select all from users. Great, so as you can see here, we got our users table that has been created. As you can see, user ID, username, user email, bio, password, and avatar. That was successfully created. I'm going to close this, and we will continue with our application. So let me close this. Next, we need a way to access our users table. So for that, I will go inside this DAO package. I'm going to create a new package that I will name user. And inside this user, I will create an interface that I will name user DAO, data access object. This is going to be an interface. Now this interface in this interface, we're going to declare two methods. On one hand, suspend function insert to insert a new user. Now to insert a new user, we need params that I will call sign up params. We're going to create this class later, and this will return a nullable user. This from our model package. Now we also need another method here that I will call find by email. This is going to take an email as input and return a nullable user. Great, so let's quickly create these Sanya params, and for that I will go back inside this model package and create a new Kotlin file that I will name auth. Now it's inside this auth that I need to declare a data class called Sanya params. This represents the parameter that our user will pass to register a new account. So for that we need first their name as string. We'll need also the email and the password of our user. The same way I'm going to have here a sign-in params for the user login. So this will have just the email and the password quickly. Now since these classes here will be serialized by Kotlin X serialization library, we need to annotate them as @serializable. Great, now come back inside our user DAO interface and import the Sanya params. Next we need to create an implementation for our user DAO. Select buff method. Great, now to insert a new user we're going to perform a database queries. So I will create quickly a helper method inside our database factory. Go back inside database factory.kt. Here I'm going to create a generic helper method to execute database queries. So this is going to be a suspend function. It's a generic function on type T. We'll call that db query. Now this db query will take a block which will be a suspend function that returns T. And so from here this will start a new suspended transaction using dispatchers.io, and then inside call our block function. Now the block function will be the actual query that will be passed, which returns type T. Alright, we're going to use this db query for all our database queries that we need to perform inside our application. So let me quickly go back inside user.dao.impl, and we're going to call this db query. You need to import that. Great, so first of all we need an insert statement. I will declare a variable here that I will call insert statement. So I will call our table user row dot insert. Now I'm going to first of all call it dot name be equal to our params, not per user, but params dot name. So the same way I will do the email and the password. Great. Let me add space here. Now below this insert statement, I will call our insert statement dot resulted value, which is a list of result row. If this isn't null, that call single or a null. And here, if we get a non-null result row, we need to convert that to our user object. Now for that, I'm going to quickly below the find by email, create another helper method, private function that I will call row to user to convert the result row to our user. This need a row, which will be a result row, and return a new user. So we will return a user. For the ID, we'll pass row. user role dot id. So I will do the same for the name, bio, avatar, and password quickly. Great. Now we need to call this row to user to convert this result row to our user object. Call row to user and pass it. Now this will be the returned value, like so. Now we need to implement this find by email quickly. I'm seeing that my battery is low. So from here we're going to return our DB query. We call DB query and then call user row, which our table dot select. So we will select based on user row dot email if that equals equal to email. Sorry. Oops. Then we need to map that using row to user and pass it. And since this is a list, going to get single or null, like so. So I'm going to plug in. Alright, so next we need a repository. Now it's at the repository layer that we're going to implement the logic to sign up and sign in the user. So let me close this. So I'm going to create a new package at our main package here. And I will call this repository. And inside this repository, I'll create a new package that I will call user. Now inside this user package, I'm going to create a new interface that I will call user repository. Select interface. This interface will declare two methods. On one hand, sign up, which will take params as sign up params, and need to return a response of type auth response. We're going to define these classes in a moment. We also need another method here, sign in, that will take params as sign in params, and also return a response of type auth response. So let's quickly go on how to create this. First of all, we need the response. This is going to be a seed class. So I'll create that inside a new package that I'm going to create. This package, I will give it the name util. And inside this util package, I'm going to create our response, which will be a seed class. We don't have seed class here. Right, so let's quickly go over that. Seed class response. It will be a generic class on type T, and this will take in the constructor a val code, which will be an HTTP status code, and the default code will be OK. And it also need a data that will be of type T, our generic type. And then here for our seed class, we will have first of all a success class, success response, generic T. Let me add one more S here. This will take in the constructor data and extends our response T, provide the data as data. We're also going to have an error response. Now this error will be also generic on T. For the error, we need an HTTP status code and data. extend response for the code. We're going to pass code and data directly, like so. Now if we go back, we can import our response that we have created, this one from our package. Now we need to create a auth response, and for that I'll go back inside our model and auth.kt. Below this sign up params, I will have another data class that I will call auth response. Great, this auth response will have on one hand a data that will be of type auth response data. It's a nullable class that we're going to create, and it will also have an error message in case there was an error. That also nullable. Now let's quickly create this auth response data class. So this is the response that we're going to return to the user. On one hand, we'll have the ID, the name. Let me quickly copy this. Oh, we don't have that. So not the email, but by you. I'll type string. So we're going also to return a token. We'll return followers count integer, default to 0. Following count as well will be an. Now these two classes are serializable as well. So add that annotation quickly. Serializable. And now go back inside our user repository and import this auth response class. Next, we need to create the implementation for our user repository. Great. Now to register a new user, we first need to make sure that another user with the same email doesn't exist, and for that I will create another utility method that I will call user already exist. This will take the email as input string, and return a boolean. Sorry, I didn't put that. Great. By the way, this user repository needs an instance of our user DAO. So I will add quickly that user DAO. And from here we're going to return user DAO.find by email, passing in our email, and we need to check if that is different of null. If that is different of null, that means that we already have a user with the same email, so it will return true. Now inside our signup method here, we will return by checking first if user already exists, passing params.email. So if that's the case, we're going to return an error response. Select error from our util package, and for the code we'll pass conflicts, http status code.conflicts, and for the data we'll create a new auth response and pass the error message as a user with this this email. What am I writing? Okay, so a user with this email already exists. So if we couldn't find a user with that email, that means there's no user, of course. So else we're going to now insert our user, and for that we need an inserted user that will be returned by our user DAO, called user DAO.insert for the params. Passing the params, that's what I meant. And now we can check if inserted user equals to none. That means we got a database server error. The database could not, we could not insert a new user if we got a return null value here. And in that case, we need also to return an error response. So for the code, we'll pass as internal server error, and for the data, you'll create a new auth response, and the error message, the error message will be, let's return, oops, sorry, we could not register the user, try later. Else, that means we successfully inserted our user. In that case, we're going to return a success response. What am I writing? Success response. And for the data, we'll pass a new auth response. The error message will be none, so we just need to pass in a data as auth response data. So the ID will be equal to our inserted user.id. So I will do the same for the name, bio, avatar, etc. Now for the token, we're going to generate a new token in a moment, but for now I'll pass a string as here is your token. So we're going to generate a new token later in this video. So yeah, I think after implementing the signup method, we can create a signup route to test if we can successfully insert a new user or not. Remove one, oops. So I'm going to create a new package that I will call a route, and inside this route package I'll create a auth route Kotlin file. Now in this auth route.kt, I'll create an extension method to routing from Ktor server. I will call that auth routing. Now from here I need an instance of our repository by inject user repository. We need a new route, and the path will be signup, not singup. All right, so in here we need a post request, and we're going to first of all get the parameter. For that you need to add call.receive nullable, and pass in signup params. So by calling this receive nullable and passing in the generic our signup params, the Kotlin X serialization will take the JSON object that will be passed and deserialize that. I would say, yeah, deserialize that and create a signup params object for us. Now we first of all need to check if params are equals to null. This means that the Kotlin X serialization couldn't deserialize the JSON data that was sent. So if params equals null, then we need to respond call.respond, and the status will be bad request. The message we will pass auth response with an error message, invalid credentials, and lastly we can return from post. Now if we reach this point, that means that our params are not null. We're going to get a result from our repository by calling repository.signup. For the params, we'll pass params, and depending on this result or response that we receive, we're going to call.respond. So the status will be result.code, and for the message we'll pass result.data, like so. Yeah, I think that's all we need for our signup. Now we can call this auth routing from plugins.routing.kt. We can get rid of this, we don't need that anymore. Call our auth routing. Next we need to set up our DI, dependency injection, to provide, as you can see here from the user repository impl, we are injecting, we are passing in a user DAO object, but we didn't provide any way on how to create this user DAO. And in our auth routing, we are also injecting here the user repository, but we haven't provided any way on how to create this user repository or which implementation will be used for our user repository interface. So let me create quickly a new package, DI, which stands for dependency injection. And inside this DI, I'm going to create app module file. Select Kotlin file, and I will call this app module. Call module from org.coin.dsl, and going to inject a single. So we get single of what? Single of user repository. The implementation will be our user repository impl, and passing the generic as user repository, the interface. So the same way for our user DAO, the interface and the implementation will be a user DAO. We don't need any get here. Oh, user DAO impl. Yeah. Now we can close this. So I will create a new class inside our DI package, and I will call that coin to start or install our coin. So from here, I will create an extension method to our application class. I will call that configure DI, and I will call install coin. And set the modules as our app module. Now we need to call this configure DI inside our application.kt. Open application.kt, and below configure serialization, we can call configure DI, like so. Now we can rerun our application. Alright, so our application is running now to test our API, to test our signup endpoint here. I'm going to use Postman, but feel free to use whatever API test framework that you prefer. So me, I'm going to use Postman, so I'll quickly open Postman. Alright, so as you can see, I was already working on some other on my demo project. So I will close this. We're going to create a new collection. Let's add a new request first. Now for the URL, I will go back inside IntelliJ. You need to copy this, copy URL, go back in Postman and paste that here. This is going to be a post request, and the endpoint is sign up. Now this one. So for the body, we are going to pass a row. So the content type is JSON. So I'll add a new JSON here. The name will be Mr. Deep. So the email, I will set that as Mr. Deep gmail.com. And for the password, Mr. Deep password. Alright, so I've got here a JSON object that I will pass to this sign up and test if our API is working. Now I'll click send. Alright, so as you can see, we're getting a 200 HTTP OK status. And now let's go back, open terminal, and check if a user has been inserted or not inside our users table. So for that, I'll write a query here. Select all from users. As you can see, a new user has been successfully inserted. So as you can see, Mr. Deep Gmail has been inserted. We've got our default bio. The password was Mr. Deep password. The ID is 1. No avatar for now. So click OK, like so. And let's close this. Now if I click this send method again, normally we should get an error saying that a user with that email exists. So let's test that. Great, as you can see, returning the data is null, and the error message is that a user with this email already exists. Yeah, so the sign up endpoint is working. So go back inside IntelliJ. Let me close this. Great, now let's quickly go and implement the sign-in. So for that, you need to open users repository, user repository impl. And we're going to implement this sign-in method. Alright, so what do we need here? First of all, we're going to retrieve a user. So for that, I will call our user DAO.findBy, and I will pass params.email. Now we can check if the returned user is equal to null. In that case, we're going to return an error response from our package. For the code, we'll pass here not found, and for the data, we'll pass a new auth response. The error message will be invalid credential, no user with this email. That's the error message that we're going to return if we can't find any user with this given email. Else, in case we found a new user, so we're going to check if user.password equals to params.password. In that case, we're going to return a success response. So the code will be okay. So we need just to return the data, and for that we're going to return a new auth response and the data. Let me remove this auth response data. So the ID will be equal to user.id. The name will be equal to user.name. The bio will be equal to user.bio. For the token, for now we don't generate any token, so I will write again, here is your token. Yeah, we're going to generate the token in a moment. So if the password, the user password equals to params password, in that case we're going to return a success. Else we're going to return an error response. So the code will be forbidden, and for the data we're going to return a new auth response, and the error message will be invalid credentials again, wrong password, like so. So I think okay, we need to return this, so let me add the return keyword. Great, now that we have implemented this sign-in, so we'll quickly go inside our auth-route.kt, and we're going to add the login route. So I will quickly copy this because it has pretty much the same logic. So what we're going to change here is, first of all, the path. So this will be a login, and the params we're going to receive as sign-in params. The same logic here. If params is null, then we know that it was about a request, and we will return from post. In the other case, we need to call sign in and pass in params, and then respond with the result that will be returned by sign-in method from repository. Yeah, I think that's all we need to do. So let's rerun the app and test if the login is working. Alright, I will quickly go inside Postman, change from sign up to login. So here we just need to pass the email and the password. Let's change the password and test if this is working. So I'll remove that S. So send request. As you can see, we're getting this error message, invalid credential, wrong password. Now let me add the correct password and hit send, and as you can see, we are retrieving our user. Great. Now I'll go back inside IntelliJ. I will close this. So next we are going to generate a token for our user, and for that let me quickly go back, open this plugins package and security.kt file. So I'll refactor this. Let me put this on top of the file. Alright, so I'll declare one constant variable here, private const val, and I will call that claim. So for the claim, we're going to use our email. So alright guys, now we're going to use JWT to generate a user token. Now at this moment, you may wonder, why in the world are we using JWT? Now in case you don't know, what we've done so far, login and sign up, is what we call authentication. In other words, authentication is who are you, right? We take the user email and password and we need to make sure that it's correct. Now, JWT is for authorization. That's a little bit different, even though you can read here authentication. Now, in authorization, we need to make sure that the client who sends the request is actually the same client who logged in during the authentication. In other words, authorization is what do you have access to. We're going to use tokens, JWT tokens in our case, for two main reasons. First of all, we don't need to ask our user each time that the client needs to make a request to provide their email and password. Instead, we're going to generate a token which will contain some user information, and in this case, the user email. And second reason is that since these tokens are going to be signed using our JWT secret key that we provide using a certain algorithm, you can be sure that the token cannot be tampered with. What I mean by that is that the token cannot be modified. Once the token is modified, we can be sure that the validation will fail and the user will not have access to certain resources inside our server. So hopefully that makes sense. Let me go back inside Chrome. Now, on this website, jwt.io, so the structure of a JWT, which stands for JSON Web Token, is that it contains three parts. The first part is what we call header, which consists of an algorithm and the type, in this case that is JWT. So this corresponds to this red part here. And the second part is the payload. So inside this payload is where we will put some data, some user related data, for example the email or the username or the expire date, just to make sure that when we receive a token, even though it's a valid token, we can do some additional validation, for example to check if the token has expired or not. And the last part is the signature, which will use our JWT secret to sign this token. So as you can see here, it has the algorithm and it will base 64 encode the header, the payload, and use our secret key that we're going to provide and then sign this token here. Now, if we try to modify even a single letter inside this token, you can see that the token is invalid. It says here invalid signature. That's why when using JWT tokens, since they are signed token, we can be sure that the token cannot be tampered with at any moment, and the user who sent the request are actually who they say they are. Let me go back inside IntelliJ and we're going to generate a JWT token for our user once they log in or they sign up. Alright, so down this below this configure security function, I'm going to create a new function. So let me add space. So I'll call this function generate token. Now this function will take the user email and it's going to return a token, which will be a string. Now how do we generate the token? So we're going to return jwt.create. First we need to call this create and pass in the audience. So for that we're going to use our JWT audience. With issuer, we use our JWT issuer, and with claim, now this claim here, since we're going to use the user email, this will help us do some further validation over the user token that will be provided to our server. Now you're going to see that in a moment inside this validate block. We're going to check the claim and make sure that the user has a valid token. Yeah. And lastly, you need to call what have I done here? Alright, so we need to provide the claim and the claim will be the email that will be passed in. And lastly, you can call sign, and for signing we need an algorithm, so I will call algorithm from auth.jwt.hmark256, and the secret key that will be used to sign this token will be our JWT secret. Now you can pass here also with expire at. That way you can set an expiration date so that you can make also a further validation over a user token. So for our project, I'm not going to use that, but here you can set a date for your token to expire. That will be a normal use of a JWT token, because normally a token should expire. Normally I recommend you to use this, but since in our project we don't really need that, I will skip this, and our JWT token will be always valid, but I don't recommend you to do that. So in your production product, use an expiration date for your tokens, so that each time a token expires you can generate a new token and be sure that the user is actually the same user who logged in. Alright, so now I'll go back inside this validate. So we don't need a verifier, since the Kotlin, the Ktor sample code also included this verifier here. As you can see, we are using the same algorithm with the same secret, audience, and issuer. So we don't need to write any verifier, since Ktor included that by default for us, and it's using a correct algorithm. So I will remove this. So to validate a token, to do further validation, I will first of all check if the credential.payload.getClaim, and I will pass our claim, which is the email, as string if that is different of null. So if it's different of null, in that case we're going to return a JWT principal and call payload, for payload we're going to pass credential.payload. In other case, so if the user if the token doesn't contain the email as a claim, we're going to return null, which means that the token cannot be validated, or the token is invalid. So in case a token is invalid because of the token was modified, or if the token doesn't contain this claim, which is a user email, we need to return a response here, and for that you can call this challenge block. Now inside this challenge block I'm going to call .respond. So this response here will be used when the token is invalid. So for the status, I will pass http status.unauthorized, and for the message I will pass auth response, and error message will be token is not valid or has expired. Now the next thing that we'd like to do is to call this generate token. So I'm going to open our user repository.impl, and here we need to call this generate token, and for that we'll pass params.email. So we will do the same here inside this sign-in method. We're also going to call generate token, and we'll pass params.email. So now let's test and see if a token can be generated for our new users. So I'm going to rerun the app. Okay, the app is running. Let me go back inside Postman. So I will need to create a new account here. So I will quickly pass a name. The name could be Patrick. So I will use a different email. So I will say patrick@gmail.com. The password will be password. Change from login to sign up. At the endpoint we need to test. Now you can click on send. Great. So let me take this. So as you can see here, the token has been successfully generated and a new user has been inserted. You can see the ID is 2. So let me open terminal to make sure. Now I'm going to run the select all from users again. As you can see, we're getting our second user. So yeah, here we don't insert any token, yeah, because we don't need that inside our database. Alright guys, now I need to address another issue that we're getting here, and that is we are storing the user password as plain text. What you're going to do instead is we're going to hash this password. Let me go back inside IntelliJ. I will close this. So the next thing is that we need to hash our user password. So for that, I'll create a new package and I will name that security. And inside this security package, I will create a new Kotlin file that I will name hashing service. Click enter. Alright, so I will not go deep with this hashing mechanism here. I will just use a simple hashing method to generate a hash for our user password, just to avoid having the user password stored as a plain text inside our database, because that is a security issue. So I will not go deep of how you can securely hash the password. There are tons of methods and tons of ways to do that, and you can just Google it, and yeah, how you can hash a password inside a Java program or inside even a Ktor project. So what I would like to do here, so I will create first of all a function that I will call hash password. So this is going to take a password as a string and also return the hashed password. So I first of all need to get some environment variable here, because this code I will push that to GitHub, so I don't want to include environment variable or secret keys directly inside my code. So for that I will get them from environment variables. So I will first of all declare a variable here, the algorithm that we're going to use to hash the password. So that will come from system.getEnvironment variable. And the variable name will be hash.algorithm, like so. We also need a hash key. That will come from system.getEnvironment variables. I will call that hash.secret. I'm going to create these environment variable. I'm going to add them in a moment, don't worry. And then I will declare a private val that I will call hmark key. And for that I need to call this secret key spec from javax.crypto.spec, and I will pass the hash secret, the hash key, and the algorithm. And this hash key here needs to be a byte array, so I will convert that to byte array. and this is using charset.utf8 by default, so you don't need to specify the charset since we need to use this utf8. Now inside our hash password function, I will first of all get an instance of hmark, and for that you need to call this mark from javax.crypto, get instance and pass the algorithm, then do init our hmark, and for that we need to pass hmark key, this one, and lastly we're going to return hex from io.ktor.util, and then call our hmark, do final. For the input, we're going to pass our password dot to byte array, and again the charset by default is utf8, so we don't need to pass that. So let's quickly create add this environment variable. So now we need to call this hash password when we need to insert a new user, and for that I will go to our user DAO impl, this one, and when we need to insert a new user, we're going to call hash password, then pass params.password. So we need also to open our user repository implementation, and then inside this sign-in method, we first of all need to hash the input password. So I'll call that hashed password from the user params. So I'll call hash password of params dot password. So we will hash the password that will be passed to our sign-in params. That way we can compare that with the hashed password from our database. So instead of this params.password, I would compare our user.password to our hashed password. Now we need to drop our users table because other users don't have this hashed password. So I will open terminal. Let me clear the screen. So from here, I'm going to execute this command, drop table, to remove or to delete the table. The table is users. Then put a semicolon. Now the users table has been dropped. Let's rerun our application. And the user table will be created again. And then we're going to insert new users and see if the password is hashed or not. Now let me go back inside Postman. So I'm going to run a new request to insert the same user. Let's hit send. As you can see, the user has been inserted. The ID even has changed. So let's now go back, open terminal, and right select all from users. So as you can see, this time the user password is not a plain text but a hashed password. Now let's test the login. So for that I will remove this name and change the endpoint to login. If I press send, we're getting the same user information. If we change the password, normally we should get an error message. As you can see, invalid credentials, wrong password. So the hashing mechanism is also working successfully. And I think we're going to stop the video for now. That was too long. And for the next video, we'll be back inside Android Studio. So we're going to write client code to integrate the server and make sure that it's working without any problem. So until the next video, take care. I will see you then.